Okay, so we are going to be talking about the ratio test. And the ratio test says that if we have a series with non-zero terms, then we let, and that little P symbol there is actually called rho. I'm sure they use that in this textbook for rho for being ratio. And it says take the limit of the absolute value of the n plus 1 term over the a sub n term. And if it just so happens that that ratio ends up being smaller than 1, then we say that that series is going to converge absolutely. What does that mean? If you have a numerator over denominator that's less than 1, then that numerator must end up being smaller than that denominator over time. And so we're able to then say that converges. Think about this as very similar to the geometric, series test where we have that ratio, right, being less than 1 because your numerator is smaller than your denominator as your numbers as your series, the sequence of your series gets really, really big. Now, if we're greater than 1 or infinity, divergent, and if it's equal to 1, then we really don't have any information as to what's going on here. So it's inconclusive, and we might need to use a different test in order to find convergence or divergence. Okay, so let's look at a couple examples here so that we can see how to use this. And notice in these examples, they all have a factorial. Like that's going to be a key indicator that you need to use the ratio test is when you have powers, like power functions, and you also have the factorials. So looking here at A, we have the limit as n goes to infinity, and then we plug in n plus 1, so 2 to the n plus 1 over n plus 1 factorial, and then we are going to divide that by a sub n. Now that's the same thing as multiplying by the reciprocal of a sub n. All right, let's talk through what some of these n plus 1 terms are. 2 to the n plus 1 is 2 to the n, like bases add exponents. So that is the same thing as 2 to the n times 2 to the 1. That means our 2 to the n's are going to cancel. All right, n plus 1 factorial is n plus 1 times n minus 1 times n minus 2, so on and so forth. N factorial is n times n minus 1, so on and so forth. So all of these terms will cancel with all of these terms, and I'm just left with the n plus 1 term there. So I'm going to have the limit as n goes to infinity of 2 over n plus 1. Well, as we go to infinity, 2 over n plus 1 is going to go to 0. That's less than 1, so this is going to be convergent. All right, I don't know why on this screenshot that came up here, but that's the problem down below. So let's just look at B. All right, I'm going to go ahead and erase this work here that we had. Wish there was like a faster way on this software to do that, sorry. All right. So let's look at the limit as n goes to infinity of n plus 1 to the n plus 1 over n plus 1 factorial And then remember, I'm dividing by a sub n, but that's the same thing as multiplying by the reciprocal. Okay, so here we know that this and this are going to cancel, and I'm left with n plus 1 down here. On this top piece, if I use the same breaking up the exponential power rule, then this is n plus 1 to the n times n plus 1, and this n plus 1 and this n plus 1 cancel. So let's talk about what we have left over. We have the limit as n goes to infinity of n plus 1 to the n over n to the n. And I can combine that middle piece here to be n plus 1 over n to the n. And this just happens to be, if you don't know, this happens to be the definition of E. Like that is what the number E is defined to be. So if you don't know that, you might want to take a little note that that's the case. Sometimes you might see it, let me give you just a little bit more room here. You might see it like this, like E is equal to the limit as n goes to infinity of 1 plus 1 over n to the n, because if you divide this up here, this is what you're left with. But like this is the definition of E. You might have not heard it before because you don't really need to know that until about right now. But that's something just to note and keep in your notes that like, okay, that's E. So E is bigger than 1, right? So this is going to diverge. So n to the nth power is bigger than n factorial. I think that's also an important note. N to the n power over time grows bigger than n factorial. That's what that means. Okay, let's go ahead and look at this last one. So this one's going to have that -1 piece in there because we're doing absolute value. It's really not going to matter. It's not going to really come into play, but we'll still include it. Okay, and I'll show you kind of what happens there. Okay, so we have the limit as n goes to infinity of -1 to the n plus 1, n plus 1 factorial squared all over 2n factorial. Nope. All over 2n plus 1 factorial. I'm going to multiply that by the reciprocal of the original. Okay, so again, it doesn't really matter here on my like alternating piece. I'm going to end up having that this cancels with the n, right? But then the absolute values like this all goes away. So that's all gone. Let's go ahead and think about what's happening with our factorials here. So this is squared. So this is going to be n plus 1 times n plus 1 times n, da, 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 and this is going to be that times n piece. Okay, so I'm left with this. And then this is really important that you plug in n plus 1 into the n piece because this is really 2n plus 2 factorial. Okay, notice that this went in where the n was. And so this ends up giving me 2n plus 2 times 2n plus 1, then times 2n, and da 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 da. So that's what cancels, so that you actually have those two terms there. And that's very, very important. Okay, so we have the limit as n goes to infinity. What's left here? N plus 1 times n plus 1 over 2n plus 2 times 2n plus 1. I have n squared as the leading term in the top. I have 4n squared as the leading term in the bottom. We know as that goes to infinity that that's going to be a fourth. So that's less than 1. So this last one is going to be convergent.